Good morning, students. Pushti sir again, back with you to discuss a very important situation. Just see the name of the topic, dielectric moving inside a capacitor in magnetic field. Dielectric material moving inside a capacitor in magnetic field. तो ये कौन सी बात होगी, चलो आगे देखते हैं क्या है. Before that, my credentials, I won't waste much time on that. You all must be very aware of it. So I am going to discuss an example which will clarify the difference between the EMF and potential difference further. So many classes I have discussed that. Now this is very important, which will further clarify the difference between the EMF and potential difference. The situation is a liquid dielectric. Let me write. This is the example. A liquid dielectric of dielectric constant K flows in the gap D between the two parallel plates of a capacitor with a constant velocity V bar. A magnetic field V bar exists perpendicular to the gap and the velocity. Okay, perpendicular to the gap and the velocity. Just say this. This is the gap, perpendicular to the gap as well as perpendicular to the velocity. That magnetic field be the cross marks pointing into the plane. Okay, so diagram makes it more clear than language which I have written, but you are now knowing what is the direction of the magnetic field. These two are the capacitor plates. These two are the capacitor plates. This is what? Capacitor plate. Lower one is the lower plate, upper one is the upper plate. Okay. What is the reading of the voltmeter? A voltmeter connected between the two plates. What reading is an ideal voltmeter is connected across the two plates. So find out the reading of the voltmeter. So कैसे करेंगे भाई? ये डाइलेक्ट्रिक मटेरियल है. अगर वो कंडक्टर होता, कंडक्टर मटेरियल, so V cross VVL, you could have easily told the EMF will be the VVL. VVL is the EMF. Okay, and that in case there is no resistance or negative resistance in the conducting body, it would have been EMF. The potential also would have been VVL. VVD, that is L is D, VVD. So, but now it is a dielectric material. तो मैंने क्या किया, ये चीज तो मैंने आपको समझाया था पहले भी. ये this is the reference frame fixed to the plates of the capacitor. Call it ground or S, whatever you want to call that. Now I am having one more reference frame, which is a moving reference frame, moving with velocity V bar parallel to the velocity of the liquid. So in this reference from S dash, this is also moving in the magnetic field. And what I discussed, to remember, an observer moving in a reference frame where there is a magnetic field B, what will you see? You will see a non-conservative electric field. So S dash observer will see a non-conservative electric field given by V bar cross B bar. Is S dash velocity with respect to S. S ऐसा कर देता हूं, ये है मेरा S. Fixed to the plate, or that is the fixed to the ground. But this is S is fixed to plate. So it is moving with respect to the plate with velocity v bar, which is same as the velocity of the liquid dielectric, which is moving with same velocity v bar. Okay, so this observer, S dash observer, which I shown, he will not see any moving liquid because his velocity and liquid velocity is same in magnitude and direction. So relative to him, the liquid has zero velocity. It becomes a static liquid for him. Is it okay? And what he will see a non-conservative electric field ENC, which is given by the velocity of S dash frame with respect to S, that is V bar cross V bar. This V bar doesn't change much because of this factor. I'm saying this V much less than what? It's much less than the velocity of light in free space. Then, so it is a non-relativistic reference from this S dash. So he will see V cross V. V is that magnetic field as observed by the capacitor reference frame, or even the same B by the S dash if it is moving with a very small speed compared to C. Otherwise, change has to take place. ये आप रेफर कर लो, BDL 90 है. मैं लास्ट मंथ 13 को अपलोड किया था, 13 अप्रैल को मेरे चैनल में है. ये इसका नाम है इलेक्ट्रिक एंड मैग्नेटिक फील्ड ट्रांसफॉर्मेशन इन नॉन रिलेटिविस्टिक रेफरेंस फ्रेम्स. उससे आपको ये पता चल जाएगा. So ENC observed by the S dash observer is a V of the S dash reference frame cross V bar. So that will be obviously pointing in upward direction. I've shown it here. Okay. Am I clear? Okay. Fine. But in S dash reference frame dielectric at rest, of course, the electric field inside dielectric will be how much? ENC by K, because there is a, due to what? K dielectric constant. Why it will be happening that way? Because ENC polarizes the dielectric such that its upper surface attains positive charge and lower surface attains equal amount of negative bound charge. Bound charge means charge due to polarization. This produces an electrostatic field ES downward as shown, and as you all know, if the electric field is E and within the rectangular parallel plate, rectangular dielectric medium, it reduces by E by K. En, so it will reduce electric field inside dielectric will become ENC bar by K. That is V cross V bar. V bar cross V bar by K, equation 2. So that's why this happened, because ENC polarizes the dielectric such that its upper surface attains a positive bound charge, lower surface attains equal amount of negative bound charge. This produces an electrostatic field because charge accumulation, static charge accumulation there means the electrostatic field must be there. Okay, am I clear? So let that electrostatic field downward as shown by the dotted line given this green line. Am I clear? ES means electrostatic, E bar, capital E bar, ES means electric field, electrostatic field. Which direction? From positive charge to negative charge. But ENC is upward direction. This ENC produces EMF. Electrostatic produces potential difference. This must be very, very clear in your mind. Okay, so this produces a potential difference between upper and lower plate of the capacitor. So ENC vector plus ES vector, that will give you the net field, that is ENC by K. So what is ES then? Electrostatic field then. To bring it to this side, bring ENC to this side, take minus sign out. So ENC bar 1 minus 1 by K. Yes or no? ENC, that ES and ENC 1 minus 1 by K. K is always greater than 1. So 1 minus 1 by K will be a positive fraction. So then, as you see from this equation, direction of ENC and ES will be opposite to each other. Since ENC points up, ES points down, because this is a positive fraction. So the minus sign ensures that electrostatic field direction, ENC direction are opposite. When ENC upward, ES electrostatic field downward. Okay. So the potential difference from upper plate to lower plate, how much then? ES into D. As you know, ES magnitude into D. ES magnitude is minus ENC 1 minus 1 by K magnitude. So that is magnitude wise ES magnitude will be ENC 1 minus 1 by K. So remove the minus. That is ENC, how much we got? ENC is V cross B, that is VB. In magnitude it will be VB into 1 minus 1 by K. Because ENC, as I wrote here, ENC magnitude is how much? ENC magnitude is how much? This I'll write here, implies ENC magnitude is VB, because they are mutually perpendicular. So with this I'm going to use in this equation. So ES magnitude is ENC magnitude 1 minus 1 by K, that is VB 1 minus 1 by K. So what is the potential difference? Electrostatic field magnitude into D from positive to negative plate. So that is the difference. So potential difference V between the upper and lower plate is VB 1 minus 1 by K into D. Using this equation, equation 5. So this V, the potential difference V between the upper and lower plate is VB 1 minus 1 by K into D. So this V this is the potential one, this V is the velocity. So don't get confused. So this is the potential difference. Where EMF was V cross V, VBD was here. Suppose this is a metallic conductor, so K will be infinite. So what will be potential difference? Same as VBD. Suppose there is no medium, so K will be what? K will be 1, so it will be 0. So V will be 0, because there no charge accumulation will take place. The charge there is no medium, means there will be no polarization, no bound charge, so no V will take place. But ENC will remain. But electrostatic field will not be taking place, because charge accumulation not taking place. Charge accumulation may be bound charge or free charge, but accumulation, if it is there, then potential difference must be there. So this is the reading of the voltmeter. Now, are you clear about the potential difference and EMF? I think you are. So note में क्या लिखा? Potential difference is magnitude of electrostatic dot dl integration, as discussed earlier. Keep in mind, if a conductor moves with velocity v bar, K tends to infinity, as you know. For a conductor, direct constant tends to infinity. So equation 7, VBD 1 minus 1 by infinity, that will give you VBD, as we have seen earlier. Okay. EMF is VBD ENC dot dl, V cross B dot dl, that VBD. EMF in general is not equal to potential difference. Just check this potential difference VBD 1 minus 1 by K, where EMF is only VBD. Okay. So be very careful about EMF and potential difference. This was a short video by me, as you know. Yes or no? So, okay. Not all videos are going to be long. I think you must be very, this is a very important, conceptual and helpful video, but maybe short. Okay. All the best for upcoming examinations. Many of you might be writing these JEE Advanced, and don't feel hesitant to ask me any question before you write the JEE Advanced examination. So have a good day. Thank you all.